On the other hand, you can also get tension cracks by applying axial pressure. Again, this is like that, the paperback book thing I told you. You press and it kind of bows and splits in the center. Another example is like an envelope. If you've cut the end of the envelope and you squeeze on the top and the bottom, it can bow out in the middle, and then you can grab your letter and slide it out easily. These fractures are typically parallel to the axis of compression. They're longitudinal splitting, and also when you're applying this pressure, unlike the tension case where all the cracks were kind of opening, in this case, any cracks not parallel to that sigma 1 greatest stress get closed. You're squishing it, so of course they're closing. It makes sense. Even pore spaces can get closed. So, here's the example, pushing on the envelope, paperback book, anything like this. In a rock, it'll look like this. All of these little short lines are small cracks that got closed up as the pressure was applied. And then the bigger ones are cracks that started to be caused by that pressure creating tension sideways. There was one fracture in this case that went at an angle to connect two of the different vertical ones. That can happen. Another really important, especially for anyone in petroleum engineering, is hydraulic fracturing. Sometimes we induce this on purpose. A lot of times, in far more cases than the human-induced, this happens naturally. We can have compressive stress and high confining pressure, but with fluid pressure in the pores and cracks. So there's fluid, whether it's water, brine, oil, natural gas. Remember, gas is a fluid. And sometimes will end up liquid if it's under enough pressure. Oops. And this fluid presses outward from the inside of the cracks. It's pressure, so yeah, it's pushing outward. It's like, pressure on the inside of a balloon is what fills the balloon and makes it big. It's pushing outward. So you think of these little cracks like hundreds and hundreds of little balloons inside your rock, and you're filling them with pressure. They're expanding. Well, that breaks your rock eventually. So let's look at how, what physically happens to it. What are the three ways it can grow a crack and break your rock? Well, we can have tension cracks called mode 1. We're applying tension to the sides of this block, and the crack is growing perpendicular to the tension. So we're pulling sideways, and the crack is growing upward, where that middle arrow is pointing. And this crack doesn't change direction. It stays parallel. It's growing perpendicular to the primary plane of stress. A little typo on that slide. Let me fix that. Sliding, mode 2. This is for your shear mode cracks. The two sides are sliding past each other, and the crack is growing in the direction of the sliding. The surface moves very slightly. So you think about it, until the crack goes all the way through, if there's sliding past each other, it means this left side here is stretching a little bit, and the right side here is compressing a little bit, and that's creating a lot of stress right along the crack, and so the crack grows so that this side can release that stretching and go back to normal, and release the compression on the right side so it can go back to normal. And the direction of growth is parallel to the rock surface, but perpendicular to the surface front. So the surface front is this flat edge, so like this gray shaded area here is the surface front. And then the growth is up towards the back of the block. And then we can have tearing mode, mode 3. This is kind of like scissors, a scissor action. We have slight parallel motion. They're sliding past each other. From the end, it might look like a mode 2, but as you look deeper, further back into the rock, you see that we've got this tearing action going on. So a lot of times, modes 2 and 3 could both be going on in different parts of the rock for the same fracture. Now, a special case are called wing cracks. If we have a big compression vertically with a low confining pressure, and the crack is this dark line, and it's starting to slide past each other. It's a mode 2 crack. These gray blobs are areas of high stress within the rock. They're not big pore spaces or anything. They're just, it's a stress shadow. And if enough shearing starts happening, we get new cracks forming vertically. They're tension cracks. They're mode 1 stress cracks. And this is causing the crack to change direction. So far, this is the only one where it's changed direction. Let me pause for 1 second. Okay, so in brittle faulting, faulting meaning there's displacement, not just a crack. A couple of important things. Sigma 1 cannot be equal to sigma 3, so there has to be uneven stress, and the fault surface cannot parallel a principal plane of stress. It's always at some angle. So unlike that tension crack that was perpendicular to that primary tension, which meant it was parallel to one of the other stress directions, there was no movement, there was no faulting, it just cracked. The tension cracks, when you have pressure, they're parallel to that sigma 1, no movement. Faulting is never parallel to sigma 1, sigma 2, or sigma 3. It's at some angle. There's measurable slip without contribution of plastic deformation. So if you've got folding and bending that creates the offset, that's not a brittle fault, that's folding. we get to that later. Different chapter.